So you guys can see some of my answers, but all I did was reciprocate tangent. So if we reciprocate 0, it's undefined. If we reciprocate radical 3 over 3, it's just radical 3. These answers show up multiple times in tangent. They show up multiple times in tangent. When we go and we graph sine, cosine, cosecant, and cosecant, which y values are we using when we go and graph all of those? Which y values? We didn't use, which y values did we use? Which y's? When we graphed? We used the ones, we used -1, so here's a 1. What also did we use when we graphed? Sine, cosine, secant, cosecant. We use what? Zeros. We're going to still use those y values because those are the easy ones to graph. We're still going to use those y values. And same thing with cotangent. We'll use the ones that are easy to graph. The ones I don't have to type into my calculator and figure out what the heck is radical 3 over 3. I don't know. So we're going to use the ones that are easy to graph. The problem is that where these start repeating is a little bit different than where sine and cosine repeat. So the key points we used for any of the other ones. So this is the hard part, is just you got to learn different key points. Okay? For tangent and cotangent, we like to use key points that start at undefined and end at undefined. Because what will the undefineds be on the graph? That's right. So if we can the two asymptotes, then we can graph tangent in between them. Just like we did for cosecant and secant. We had the asymptotes, we graphed in between them. So when I look for where my asymptotes are, my very first point is not at an asymptote. So my first point that I would use at 0 is 0. Then we've got pi over 4 is 1. And we've got pi over 2 is undefined. So here's an asymptote. So what we kind of decided, whoever decided this, is we're going to use these three values, and this will be like the third value that we use. That undefined, that's going to be the third value we use. So here I'm going to put my 0, 0. I'm going to put pi over 4, which was 1, and I'm going to put pi over 2, which was undefined. And if you're looking at xy coordinate here, our undefined will be right here at pi over 2. And the 0, 0 here, pi over 4. Oh, I need a scale on here. Let's make this one right here. Our pi over 4 would be at 1. Okay? So when I'm talking about graphing asymptotes with the stuff in between, we decided to go backwards to get the other asymptote. So when we go backwards, we're going to like negative pi over 4 to negative pi over 2. We're going backwards. You guys understand what I'm talking about? No? Yes, no, don't know, maybe, not sure. So what I'm talking about on the circle is, like if we do the circle, we've got 0, we've got pi over 4, we've got pi over 2 here. But I'm going backwards because on here, like if I went forward, I'd go, you know, the counterclockwise around. But on here, I'm going to go backwards, so that's going negative. and I'm going to use this value, and I'm going to use this value. So we didn't do that. We didn't do that on our table in the front. Our table in the front, what is 7 over 4? What's the answer for 7 pi over 4? That's -1. That's the exact same thing as negative pi over 4. They're in the same location. They're coterminal angles. And then 3 pi over 2 is going to be the same place as negative pi over 2. So when I find 3 pi over 2 over here, that's undefined. So I'm going to use those values as well. Okay, this picture in our section, just heads keep drawing this picture. When you do tangent, you're using these points. When you do tangent, you're using these points. Okay? So now that we have the key points, we can finish graphing them. And then you guys are going to tell me how I can do more of the graph than just what I've done right here. What's something else? What is something else I can do? We've done it before. What do you think, Jacob? Repeat the pattern. That's exactly what we're going to do. We're going to repeat the pattern. So I'm looking at my asymptotes. Negative pi over 2 to pi over 2. Those are like 4 blocks apart. So I'm going to go to the next 4 blocks, put another asymptote there. Or did I count wrong? Yep. Let me fix that. Okay, we've got some asymptotes there, and then we're going to repeat the pattern. Now, when you connect these, you haven't seen this unless you've graphed it in the past or graphed it on Desmos when you were fooling around with Desmos the other day. This is what they look like, and I'm going to come around and check. If you're going up, the graph should be concave up, kind of like a parabola. And if you're going down, the graph should be concave down. So as you draw those, I'm going to kind of like walk around and just make sure that you're not doing extra things. Some people have trouble with these. If you got those, see if you can find the asymptotes. In the same way we did it with secant and cosecant. Just one hell, I think, was your pencil. It's in it, and you fixed it over here. Just on this one here. Make sure that happens. I had that bumped in it. So be careful. So like when you're going down, down over. But you weren't quite sure we're gonna do it. All right, find the asymptotes. Find your asymptotes. Nope. Where's the first not negative asymptote? Pi over 2. So we're going to say x equals pi over 2 plus how apart are they? Pi? Yeah, pi. Yeah. So we'll say k pi, where k is an integer. I need to not use marker. It's really fat when I write. So our domain should be x does not equal pi over 2 plus k pi, where k is an integer. Okay, the period. So this was a little bit different than sine and cosine, because for sine and cosine, or for cosecant and secant, remember for secant and cosecant we had like one up and then one down. And the two of those together make one full cycle. One full cycle for a tangent is one of these purple curves, which if I went all the way around the circle, it would be two of these. So the tangent, the period of the tangent is way shorter. The period of the tangent is pi long. Now remember, if we have any stretch or shrink, horizontal stretch or shrink, that's going to change our period. But this is the parent function. And then the range, there's a lot of different pieces, but we're just asking how far down does any of the pieces go, how far up do any of the pieces go. Negative infinity to positive infinity. Okay, so when we do cotangent, we want to kind of set it up the same way we did tangent. We're going to have cotangent start at undefined and end at an undefined. That's what I know for sure, is that both of these are going to start at undefined and end at undefined, so that we have the two asymptotes. And when I go and I look over here, where is that first undefined for cotangent? Right at 0. So I can actually go 0 through, where's the next undefined? At pi. So I'm going to go from 0 to pi. All of the x values have to be evenly spaced. So with me not even looking at the other side, I can figure out what these are going to be. Because if I'm going from 0 to pi, what's that middle one going to be? It's going to be pi over 2. And be between 0 and pi over 2. Pi over 4. They're evenly spaced. So then if I'm going up by pi over 4 each time, this will be 3 pi over 4. And then if I'm not looking at that table, if I'm just thinking about cotangent going from 0 to pi, my first one is at pi over 4. What is the cotangent for pi over 4? It's 1. At pi over 2, it's going to be 0. And at 3 pi over 4, it'll be negative 1. So a lot of my students in the past will get cotangent and tangent confused because they look a lot alike. But they do have different values in different orders. So we'll go and we'll graph our asymptotes. We'll follow the pattern, keep going. I'm going to write the equation for my asymptotes. What's my smallest asymptote that's not a negative? 0. So I'm not going to write 0. I'm just going to add on, they are pi apart, so pi k or k pi, where k is an integer. So my domain is the exact same thing, but does not equal. At pi over 4, it is 1. At pi over 2, pi over 4 is negative 1. If it's going up, it's got to be concave up. If it's going down, it's got to be concave down. So our period is pi, and then the range goes from negative infinity to positive infinity. When you're ready to try transformation, flip the page over. right, you guys looking at next example? Or I should say, really, it's like the first example. So I notice it's tangent, and the tangent points, and if you copy this picture over and over again with me, you'll remember it better for our next section that we do in here. Our tangent points go from the negative pi over 2 to positive pi over 2. They go from negative pi over 2 to positive pi over 2. So right in the middle of that is 0. And then in the middle of those is negative pi over 4 and positive pi over 4. So those are the points that we use for tangent. And then our y values should be, if we've done it correctly, undefined to undefined, with 0 in the middle. And we now have to figure out which one's positive 1 and which one's negative 1. So at negative pi over 4, we are in the fourth quadrant. Should that be positive 1 or negative 1? It should be negative 1. And in the first quadrant is positive 1. So we have our key points. What's that 2 out front tell me to do? Vertical stretch, that's what's going to happen. What's it tell me to do with the table? What multiply what by 2? The y values, yeah. So we take our y values, multiply by 2. I'll do that in a moment. What's the 1/2 tell me to do? What's here? X values by 2. We have to flip it. We're going to multiply our x values by 2. That's a good question. Do I have to factor? Yes. So I was going to ask you, what do I do with the pi over 8? And your answer should be nothing. You got to factor it, right? You answered even quicker than I could. So we do have to factor it. 2 tangent. We're going to take out the 1/2. We'll have x minus something left over, plus 3. So if you're taking out a half, you're dividing it by a half. I don't do division by fractions. I multiply by the reciprocal instead. So I'm taking that pi over 8 and I'm multiplying it by 2. What do I have? Pi over 4. If you're not sure that you did it right, if you're like second guessing yourself, just like multiply it back in. Is 1/2 times pi over 4 pi over 8? Yes. So now what do I do with the minus pi over 4? Austin, what do I do with the minus? Add it to the x's. Plus pi over 4. What do I do with the plus 3? Zell, what do I do with the plus 3 out here? Add it to the y's. Remember, if you do anything vertical to the undefineds, nothing happens to them. They just stay undefined. And then I'm just doing my math really fast. You guys can do your math by yourself when you do your assignment. So I got, for my x's, I got negative 3 pi over 4, negative pi over 4, 3 pi over 4, 5 pi over 4. So I'm going to put asymptotes at negative 3 pi over 4 and 5 pi over 4. So if you're not sure, these are all evenly spaced, so I could go find negative pi over 4, 1, pi over 4, 3, 3 pi over 4, 5, and then from there I could figure out, oh, this must be 5 pi over 4 here. They are all evenly spaced. I did.
Did she? I
Oh,
didn't
she
see
just
it.
only emailed me, maybe?
Maybe, I don't know.
I heard her and Terry and Jenny all emailed me. Did you hear back from any of them?
Mm-hmm.
Jenny said she doesn't do it. Terry and Jennifer said they do.
Oh, okay.
But that might be my day 3.
Yeah.
Because they also said they spend, sounds like 2 weeks on graphing lines or something ridiculous, but I don't know.
Okay.
Jennifer sent me like all this stuff. I can forward you.
I'll probably do the chapter 3 test without it.
Uh-huh.
And then, like, when we get back, then maybe that's something we can work on as an opener, but, like, I don't actually, like, quiz them over it.
Mm-hmm.
Like, so they've seen it,
right.
but...
Right.
I don't...
That's where I am.
Yeah.
That's where I am.
Okay. Alrighty. That's all I was wondering.
All right, guys, period. It normally is pi, but did we have a horizontal stretch or shrink? We did. So what do I do to this pi? Multiply by 2. The exact same thing I did to the x's. 2. So that's not us. 2 pi. Vertical shift. Did we go up or down?
Yeah.
Where did we go? Up 3. Kennedy, did we have a phase shift? Left or right?
Yes.
What do we do? Right, pi over 4. Didn't write my asymptotes yet. X equals, Michaela, can you help me with my asymptotes?
X equals pi over 4 plus
All right, hold on a second, Michaela. Pi over 4 doesn't have an asymptote there.
oh wait, you're right. Sorry. 5 pi over 4.
5 pi over 4, okay. Plus, and then we have to figure out how far apart they are. So on my graph, 2 blocks make pi. On this graph up here, 2 blocks make pi. And these are 4 blocks apart. So how far apart are they? 2 pi. So we're going to do 2k pi. Where k is an integer. Do we have a spillage?
No.
Okay, good. So domains can be the same thing as the asymptotes only not equal to. So 5 pi over 4 plus 2k pi, where k is an integer. And the range is negative infinity to positive infinity. One more. You start it, I'll catch up. You start it, I'll catch up. Last one. If you want to find the decimals, and that way you can connect better, but I think it's actually hard. Oh, like your asymptote or something. Did you have some like concavity issues? right, you guys, when you pick up your, do your key points for cotangent, we want to use the key points that go from 0 to pi. From 0 to pi. And those should be the undefined parts for cotangent. So 0 to pi, we have pi over 4, pi over 2, 3 pi over 4. Pi over 4 is positive. Then 0, then at 3 pi over 4, it's negative. We have transformations. We've got to multiply our y's by 3, then subtract 1. So when I go to put my asymptotes, I'm going to have an asymptote at negative pi and at 0. Then I will follow that pattern. Why does this one look so skinny? Huh? Does this one have a vertical stretch? Oh, so vertical stretch, I haven't even drawn yet, but the vertical stretch would affect up and down. That doesn't affect how wide these lines are. What affects how wide these lines are? What is it? But like, I'm looking at this and I'm looking at that one. Those were really wide. These are skinny and they're wide too. Why does this one look so skinny?
The other one's
Yeah, we scaled this one differently. Okay, so I don't want that to confuse anybody. Like, this one is what it's going to look like if you have no stretch or shrink on your homework every single time. This is what it'll look like. We're just zoomed in on. We didn't really need to graph that many for the parent function. Okay, at negative 3 pi over 4, I have 2, and then negative 1, and then negative 4. And then just watch your concavity and follow your pattern. Oops. And then use erasable markers for all the mistakes you make. No, just me. You guys are using pencil, right? Right, Jacob? You know, right?
Yeah, I just have
Do you guys have Amazon Prime? Okay, then you don't even have to get around to buying it. It's like 2 clicks. Done. They'll arrive in the mail. That's how I got mine.
watching movies, so I can't get a job. I don't have money to
Right. That I didn't mean do you have it. I meant does your parent have it? You could just ask them, but maybe they'll say no. Say, Criswell says I have to have something that erases. I'm supposed to be using a pencil, and I don't use a pencil in her class. What is the period for this one? Help me out. Let's do it. What's the period? Let's go fast. Hi. Okay. Was there a vertical shift? Phase shift. Left pi. Domain and asymptotes. X equal to or not equal to, what's the first one? Okay, so we have 0. We add on k pi or pi k, where k is an integer. And then range goes from negative infinity to positive infinity. You have a worksheet. It is 6 questions. You can do that in class or you can do it outside of class. The rest of class we have time to work on our roller coaster projects and or the assignment. I was helping a lot of people yesterday with coaster projects. This part is sometimes just fitting those pieces together so you're not going to kill the people that ride your roller coaster. Also, something to keep over. There were a couple things that people yesterday that everybody hears this. When you do have your roller coaster, all right. I don't know. I overachieved a bit. Okay. It has to start and end at the same place, but how, if I looped this around, how would this actually connect right here and here? I mean, like, if I looped it around, like, if I move this one over here, it would be like a point. There? No. I don't think your coaster is going to be able to do that. Unless you can come up with, like, a really creative car that can do that point. And then you spend all your creativity time on making up the cool car that would do that. Otherwise, you need to spend time on just making sure that maybe the coaster has something at the beginning that flattens it out. Or maybe a little bit at the end that also flattens it out so that people could get on and off. Okay? And then the other thing that we talked about yesterday about the coasters is that when you do Flipgrid, because you have to make a video with Flipgrid to do your presentation. Fifth graders get their votes. When you do Flipgrid, Flipgrid has, has the ability to, I'm going to show you, this is your class, and I have the thing the code posted on Canvas so you can get to it. Let me log in real fast. Tap the green plus to make one. So nobody's made one yet because this is your class. Okay, and then I'm going to make a video real fast. Here we go. Hi. Okay. They do. They do have some other cool things over here where you could like put stickers on, I think, and like do whatever. And then they have like this whiteboard thing, which is new, where you could like write stuff if you want. And it's just recording the video as I do that. I don't even know what this is. Oh, cool. Okay. Make it blue. Make it whatever. You can put text on there if you want a title. Anyway, after you're done doing that, there's some other stickers. Stop. Okay. There's some other things. There's like add a sticky note. Okay. After you're done doing that, then you have to do your selfie. Hey. Okay, there's my selfie. That's kind of scary. Sorry. At the end, once we get there. There we go. Don't close the window. I did a long video, I guess. Oh my gosh, I did not expect this to take that long. How's your day? Okay, so then at the end you can title it, which is optional, but this is the part I really wanted to show you. I did this whole thing just so you could see this link right here. If you are like really into video editing and like you have your own YouTube channel and you know how to use that green screen in the hub and like you want to make a way cooler video, I think you only have a minute and a half on here. If you want to make a way cooler video, you could do your Flipgrid like, hey, I just want to let you know we made a video, but you got a link, it's, the link below, click, or something like that. And then the kids could click on that and watch your actual video on YouTube. So I'm not going to like hold you back from doing something where you really enjoy that kind of stuff. I know I had a kid make a video last year. It was really cool on YouTube. But you just have to link it there. What was I going to say? I forget. Anyway, you're trying to get votes from them. So I know what I was going to say. If you do go out of your way to do something really special and you overachieve, then your score will probably be a little bit higher than it should be because I like to give extra credit for overachieving. Okay? That's on the graphs too. Like if you have 16 equations, that's an overachievement. You only had to have 3 minimum. So if you overachieve, I can give you some extra credit. Okay? All right. Now I will not be submitting that video. Sorry. confirm. Okay, so that video, Fourth Bell roller coaster on Canvas. There's the link to get you there, so you can find it there. And you have the rest of class before and after lunch to work on your coaster project and or your assignment, which I'm happy to. Oh, and the thing printed out weird again. So if you have tables and you want to use those, you're going to need them. If not, there's tables. Well, how many watch videos? Yeah, we'll watch them. In class. Yeah.
Oh, you want to make a YouTube video? What's up, guys? It's Alex Gavin here. Today?
Yeah. So the need to get some tables. You guys can totally work on the roller coaster project from here to the end of class. Remember, to this project, there should not be one person carrying the team. There should not be one person doing all the equations. You like 20 minutes?
I'll do a
The grid. I have the grid paper in front of the room. I have the grid paper. You're more than welcome to use whatever paper you want, but this has grid on it. Paper over here that's not grid. So I also have some paper that's not grid paper. It's a blank background, but you have to trace a grid onto it. So first this. I think so too. Thank you.